All right. In 721, we're going to set up some word problems like you've done since algebra and geometry. You've got your investigation that you want to model, explore the situation. You've got the scenario. You can read it, you get it. It's just a matter of help me set this up so that I can solve the problem. Just tell me what to do. In 721, we're going to go through some steps that I would like you to check off before you ask those questions. Like, can you set this up yourself? Typically you can. It's just the practice of they're always going to be different. You're always going to have new scenarios, but kind of going step by step through how do I set up these problems. So we're going to start with 732 together. Taking notes, writing down the diagrams, the equations as we go through them, and then we'll try another one on our own. So let's go ahead and start. I've got it written down here. The volume of an open top rectangular box is 4,500 cubic centimeters. The length of the rectangular base of the box is twice the width. Find the height so that the surface area is as small as possible. So we may read it twice, or we may understand it right away, but in 32, the first thing we want to do is always draw a diagram. If possible, can we draw it in proportion? So we're drawing an open top rectangular box, and the length of the rectangular base of the box is twice the width. We can try to get it in proportion, so we can watch me sketch in this open rectangular box. Same 3D shape we've always made. How's that look? Decent, sure. Let's say this is our open top right here. This is our length, which looks like it might be twice the width. And then here is my height. How's that look? Just fine. So we've got our picture drawn, rectangular base, length, width, height. Now, putting in our letters for our box, we have our length being twice the width. So if I call my width x, then I can call my length 2x. That makes sense. And then we also want to do our height because that's what we want to optimize. Got our variables. The other things we talk about is volume and surface area. Then we want to fill in our equations. So the volume of this box is going to be x times 2x times h. Open top doesn't really matter for that. And then our surface area, the surface area of our bottom right there is going to be x times 2x. Only have one of those sides because of the open top. This side here and this side here have the same dimensions. They are x times h. And then let's go for another color here. The front and the back, now I've got that all jumbled up, are 2x times h. And again, there were two of these, and there's also two of these. I'm going to simplify those equations. So we'll have 2x squared plus 2xh plus 4xh. So our surface area equation is going to be 2x squared plus 6xh. All right, got our equations, got several variables, but don't worry about that. X represents our width, h represents our height, surface area, volume. So finally, identify the variable that represents the quantity needed to answer the question asked. The question asked is, find the height so that the surface area is as small as possible. So we've got our surface area, Now we've got a height in there. Once we know which variable or equation we're talking about, we want to get that equation in terms of just one variable. Right now we've got x's and we've got an h. So we use our other equation and we try to make a substitution. We know that volume is 4,500. So we substitute volume as 4,500. And x times 2x is 2x squared times the h. Now, if we divide by the 2x squared, we get an equation for h that we can substitute into the other equation and make it all x's. So h equals 4,500 divided by 2x squared would be 2250 over x squared. So then if we plug that guy in here and do a little simplification, surface area equals 2x squared plus 6x times 2250 over x squared. We're going to cross out this x with an x squared, and then 6 times 2250 is 13,500. So then we've got surface area equals 2x squared plus 13,500 over x. That's our one equation that we want to minimize with one variable. So I plug this into my graphing calculator, get a nice window using my table, and I'm going to draw a really rough sketch here. But the point is, the left side of this graph is kind of disjointed, but the right side has this spot that looks like this. So obviously in x's, and we're talking about lengths, we're not worried about the left side, the negative side of the graph. So we must be looking for a minimum spot right here. So we'll zoom in on our graph, we'll get what x equals, and in this case I think it's 15. And it gives us this y value of 1350. Now, x is 15. This 1350 is our y value. That's actually going to be our surface area when x is 15, and that answers another question later. And then from our previous equation, if h was 2250 over x squared, and x is 15, we just put that in to find our actual h. So h equals 2250 divided by 15 squared, which is going to give us h is 10. So that's our height that would make our surface area as small as possible. Now it didn't ask, but understanding what the y value was, I feel, is another important part of this problem. So h is 10, and our smallest surface area would be 1350 square centimeters. All right, now you try.